Welcome to the Deep Dive. Today we're getting you fully up to speed on the 2026 winter climate and storm risk assessment for December through February.
Yeah, and after going through all the global sources, it's clear we're looking at a pretty high variance season.
Driven by two conflicting weather behemoths, right?
Exactly. You've got a weak La Niña in the Pacific on one hand, and then some serious instability building up over the Arctic with the polar vortex.
Okay, so let's start with La Niña. The sources say it's weak, but projected to transition.
Right, and that's the core problem. It's forecast to shift to ENSO-neutral, or La Nada, right in the heart of winter, January, maybe February.
So a mid-season pivot. That must make traditional modeling a nightmare.
It does. It fundamentally breaks it because you're switching drivers halfway through. So our mission here isn't to find one single prediction.
It's to isolate the actionable risk inside all that uncertainty.
That's the goal.
And that difficulty seems really obvious right away in North America. How does a weak La Niña create such a massive north-south divide?
Well, the weak label is a bit misleading. It's still strong enough to enforce a really sharp thermal and hydrological split.
Okay, so what does that look like on the ground?
The data points to a severe winter for the northern tier. So think upper Midwest, the Great Lakes, northern Rockies.
And they're facing what? Sustained cold?
Sustained deep cold, yeah, and a much higher risk of high-impact blizzard events.
Which is a direct threat to supply chains, a logistical headache.
A huge one. Meanwhile, the South is dealing with the opposite problem.
Warmer and drier for the Southeast and the Gulf Coast.
Exactly. So drought persistence, which has already been an issue, is a very real worry heading towards spring.
But there's an exception to that clean split, right, up in Atlantic Canada.
Yes. This is where it gets interesting. For Nova Scotia and eastern Newfoundland, the models show a risk of what we call messy storms.
Not just heavy snow, then.
No, it's a dangerous mix. Freezing rain, ice. And that ice accretion, that's a direct threat to infrastructure.
A grid killer. Much more dangerous than just a lot of snow.
A much bigger risk for power outages, definitely.
Okay, let's pivot to the other global player here. The polar vortex, the PV. This sounds like the real wild card, especially for Eurasia.
It is. We're already seeing rapid snowpack growth across Siberia and Canada.
So we're building up a massive reservoir of cold air. It's like loading the cannon.
That is the fuel source. And it points us toward the critical high variance risk here, which is a potential stratospheric warming event.
And for those of us who don't track atmospheric pressure at 100,000 feet, what does that mean?
It's basically a rapid warming event high up in the stratosphere that can destabilize the polar vortex. It can knock it completely off balance.
So it kicks the legs out from under that swirling cold air that's usually locked over the pole.
Precisely. It can cause the PV to buckle or even split entirely. And when that happens, it pushes all that Siberian cold air violently southward.
Into Europe.
Right into Europe. So while Western and Northern Europe might have a mild, wet start to the season, a PV collapse would completely override that.
And bring a severe, rapid onset cold wave.
Yes, probably late January or February, hitting Central and Eastern Europe and West Russia the hardest.
And the sources are flagging the Caucasus region as a specific hotspot. Why there?
Because the geography there creates a perfect trap. That frigid Siberian air gets funneled down and then clashes with moisture from the Black and Caspian Seas.
Which creates a recipe for disaster.
A major potential for a localized disaster. We're talking severe, heavy snowfall and icing. Think snow load and infrastructure collapse.
So let's pull this all together. What's the strategic takeaway? It's a complex season.
Very. It's defined by that transitional La Niña and this very unstable PV. The main thing to remember is that a seasonal forecast gives you probabilities, not certainties.
Which means just relying on the 3-month average forecast is a huge mistake.
It's a critical error, especially for tactical planners. You'd be ignoring the actual risk. You have to be watching the sub-seasonal drivers in real time.
Like the PV dynamics in January and February.
Absolutely. That's the only way to anticipate these tail events. The low probability, high impact cold surges are the real threat to business continuity.
So since that vulnerability to extreme cold exists even with a mild mean forecast, you really have to ask yourself, how robust is your energy and logistical contingency plan for a 3-day rapid onset polar plunge that the forecast says only has a small chance of happening? That's the knowledge you need to act on.